Chapter 5, Structural Modeling. Right. So from the topic, we understand that we wanted to use graphic representation to display relationship between probably objects, classes, or components. So that related to class diagram, object diagram, or component diagram, right? Because we wanted to know their relationship. So relationship may be association, right? So the target A associate with target B, right? The target so could be class, could be components, or specifically, we're going to use object to describe the relationship. If A want to communicate with B, right? So A should know that if I send a message or a request to B, then it is supposed that B can provide the data to the sender, means A, right? And build a communication, all right? So sometimes A contains a lot of attributes and operations. It is very complex. Then it will be very hard to be reused. All right? If we wanted to use something as simple as possible that can be shared by others, right? Like last time when we talked about use case, if a use case to be included, then the use case will be simpler because that use case will be shared by other use cases. The same idea is we wanted to share and they will not be so complicated, right? Otherwise we cannot change that. So if A is very complicated, then we want it to be easier to be reused. We might take out some part from A that become another class, right? Then when A wanted to do something, then it cannot ask itself. Should send the request to the other, right? So then the other will provide the data to A because they are separated. Okay. Then A send a message to B. We only know they send message. If we have no idea about how they perform that, just a send message, and it is a structure, right? We only know A and B, and they have a connection. This connection could be association, right? Association, like I said, A needs data from B, but not B from A. Then their association is one way, unary. Unary means one way, one direction. A ask data or X service from B. It's unary, right? Unary. One way. It's unary association. A as B and B also as A, and A need to know B, B need to know A, then become bi-direction, right? So there will be two-way. Two-way, all right. So binary association, A and B. A send a message to A, and B sometimes need data from A. So there'll be two ways, one way and two way. That's the association, right? Association. And with the unary association, A asks service or data from B. That means that whenever B changed, B will be affected, right? Because A depends on B. A asks service from B. So whenever B change, A will be affected. That's a unary, right? Unary association. You probably will see that it's a weak relationship, but no, there's no difference. Usually, they will not communicate, so often probably. That is weak. But also, if it depends on B, then B's power is over A. Because whenever we say power, it means related to data change, right? Whenever the data change, they will affect the others. So B's power is over A, right? Depends on B, right? If it's binary, then B might ask A, and so that's A, right? A as B, B as A. It's binary, right? Binary. So if A depends on B, A needs to know B, but not the other way. B doesn't need to know A. Okay. So we'll never know. A wanted to ask something, you gotta make sure B can provide it. But how can we be sure? B knows it. When A send a message to B and B cannot do it, that means there's something wrong, right? So how can we know it? For a novice designer, right? Novice means you are new, to the design, and you probably would make this mistake, right? So we need to examine the matter, right? Probably we need to act. Something is missing, right? The matter is missing. We need to fill in B, all right? If you are a novice designer, then you should know what B should have, and then B can do the thing, right? So that is related to a subtopic of today, right? It's a CRC code, right? So CRC is a text-based, right? So text-based is not that easy to communicate, right? So that's why we prefer to use modeling, right? Modeling is a graphical representation. So we can use graph, picture, right? The things that to communicate. But both of them, they are structure, modeling, right? So the beauty of the structure modeling is that if you know how to diagram, then you probably are not familiar with the domain, right? The domain. When we say domain, it means application domain, right? So you probably are not familiar with the application domain. If you wanted to design a system, No. And you should know their business processing. That is the application domain. We need to know that. Then we should provide our know-how. There will be solution domain. So we have two domain, application domain and solution domain. Solution domain usually, there is a lot of jargon. There could be symbol, could be special words, right? It's only the technician can understand. That's the solution domain. So that's why you need to learn how to diagram, right? Learn the UML, because we're going to provide a solution, right? That is solution domain. If you are not familiar with the application domain, but you know how to structure that, they were easier, for you to understand by reading the diagram or drawing the diagram, right? So our PowerPoint file providing sample, Mary was not an expert in some domain, but for her, it is not that difficult to catch up, right? Because she knows how to diagram that, right? The structure modeling that help us to understand the whole picture, right? Whole picture of the item. I said could be classes, could be objects, could be component, right? But we are not going to teach you components diagram. It is not that difficult. It's going to see that server, client, hardware, all this, their relationship structure, right? Same as class diagram. But if you wanted to understand more specific instance, there will be object diagram. We use data, right? The data to express, right? It will be easier for us to understand, is this a reasonable or something missing? That's right. So let's see. So we have two domain, right? Problem domain, solution domains. Technician, should be good at solution domain, So you know how to diagram that, but probably not an expert. Usually we are not experts in this domain because we take our expertise to solve a problem. We need to understand the problem domain, right? With the problem domain, with diagrams, then the technician can communicate. Okay, that's so you have already knows the polymorphism and dynamic binding, right? Okay, Lucas, let me see what you do. What are you doing? What are you doing? What is polymorphism? What is polymorphism? Do you understand polymorphism? No? Since you come here, pay attention, preview and come here. Otherwise you quit. No, quit this class. You're absent so many times, and you come here, and you do your thing. I would say that, no way, no, not do that. have a problems in listening English, Lucas? No? Do you understand what I said? Do you understand English? No? You don't understand. 你不懂，你听不懂英文，那不是一个理由。有很多学生不见得听得懂，完全。但是你来这边做你的事情，我不喜欢。啊，我告诉你，也就是说，如果你听不太懂，你可以 ask for help，你知道吗？那个不是一个理由，就是你既然来到这边，你要对自己负责，不是对我负责。我不高兴，并不是跟我无关啊，你知道吧？学不学是你的事儿。但是这是用英文上课，我会讲一点中文。你是好几次没来的，今天突然出现了，那出现要做你的事，就不太好呀，对不对？那不清楚的话就想办法跟上吧，就不要忽悠，我不喜欢这样子。Okay, polymorphism is different form, right? So polymorphism, we said that could be, override, overload, right? So if we need to override, we change, right? Overriding only happens in inheritance, right? So they will not happen in one class, classes, parents and children override it, right? And the other is overloading, right? Overloading. So overloading only happens in a single class. You have the same method, but we want it to perform differently, right? So overloading. The same goal, for example, but you want it to go differently, or buy, or accumulate, or calculate, whatever, right? The method, but you want it to perform it differently. Could be different parameter. It could be different return type. Whatever, you should change that. Otherwise, you don't need to use overloading, right? And then, okay. So, if I ask you that we have two types of polymorphism, right? One is override, the other is overload. Right? If we wanted to compare the performance, efficiency, right? Efficiency, which one is more efficient than the other? Overriding, overloading, which one is more efficient? Raise your hand. They were related to compile time and runtime. Which one? So we need to compare compile times and runtime. So one is that we can change that at runtime, quite flexible, and the other is, it's not that flexible. Okay, Harry?
I think it's overriding because it's cross-class.
So it's more efficient?
Yes.
More efficient. Is it runtime or compile time?
Compare time.
It's a compile time.
Yep.
Compile time. Do you understand that? Answer. You don't know the answer. Daniel? You understand that? No. Sorry. No. Tom? No. Which one is compile time? Which one is runtime? Pumpkin?
overriding is runtime,
Wrong time.
and overloading is compiler time.
Which one is more efficient?
And I think is overriding.
Overriding is wrong time is more efficient.
Eh, overloading.
Say it again. So, rephrase what you said.
Overloading is compiler time, and overriding is runtime.
Okay, which one is more flexible?
Overloading.
Overloading?
Yeah.
So, overloading has an advantage of flexibility and efficiency? Both.
Eh,
Your answer should be logic.
sorry.
Then,
No, I don't know. Sorry.
second one, you answer this. Carol?
I think the overriding is more efficiency because if I just inheritance, we can make the same function have a lot of different function, but the overloading we have to in a class and try to code the same function a lot of time, and use different arguments.
Okay, so overloading, that is wrong time. The performance wrong time or compile time. Overloading.
I think overloading is compiler time.
So compile time is not that efficient.
Yeah.
The wrong time is more efficient.
Mm.
So your answer is the same as Henry, right?
Mm.
Right? So if that's overriding, so overriding is more efficient, right? More efficient. Okay. What about that they have some of that have similar answer, but some parts are different. What do you think? This is a question. It's hard to correct. So you understand that? Can you answer that? Do you understand that? Yeah. You wanted to answer? Yeah. Explain that. Your TA. You understand? Compile time. Why? Why is this a compile time? Okay, you have a reference. Okay. So that is the concept of that, right? So when we think about that compile time and runtime, right? Runtime is more flexible. You can change that at runtime, all right? More flexible. But if there's overloading, we said overloading, we preset it. So we should preset it. We preset it, we presume that, well, we need to perform three types. No. So we set the method. So it's a compile time. Very efficient. Right? Because we predefine it. Got it? We predefine it. We are not going to change that. So we predefine it. It's more efficient. All right. You want to have five kinds of behavior. We predefine five and run it. Of course, it's more efficient, but not that flexible. If there's overriding, we can change that at runtime. not efficient. All right. So you are not going to have two advantages at the same time. All right. So one takes one and not the others. Right. So it's related to performance. Performance means efficiency. All right. If we predefine something, of course, or we combine a lot of methods together, it's more efficient, but not that flexible because you should follow all the predefinition, right? You got it? So I hope you can follow. Do you understand that, Carol? Carol? Got it? All right. So if we are sure that follow the 10 steps, we bind it together. It's more efficient, but it's not that flexible to change that because we presume that take it. No, that is the package, right? More efficient, right? And here, dynamic binding, right? Dynamic binding, that happens, usually that happens, is more flexible, right? We can change it at the wrong time, right? So not the other way around, right? But dynamic binding, we should be cautious about something wrong about the logic, right? So I'm going to give you an example like that. So here, we still can see that decisions made at wrong time may induce runtime error because if there is predefined, we already test it, all right? We'll be sure that they will be okay, right? Predefine that. But if there is we provide more flexibility, might have runtime error or illogical. So you should test it later, right? You got it? Do you follow? Okay. Let's take an example. I hope you have already previewed that, right? Previewed a vehicle. It is an example of dynamic binding, right? So that example that represent that we have transportation tours, right? Transportation, they can take us from location one to other locations, transportation, right? So the example talk about transportation tour. So we have four kinds of transportation tour. One is one is street racer. It's a kind of transportation tour. We have the second types of transportation tour, Formula One. We have helicopter. We have jet. All right. So now we have four types of transportation tour, and we can suppose that they should have, because they belong to transportation, the category. So they might have similar attributes and matter, like speed, right? So it might have speed, right? And the method that's how to move it, all right? So give it move, right? Move, if it's a move move differently, the speed will differently, all right? Formula, it might have moved the same, all right? You can use a different word to describe it, like our example use go, right? You can use a move. The street racer, you know, Formula, helicopter, jet, they can move differently. Some of them might move similar. That is too, all right? Go by driving, move by driving, all right? Driving is normal speed. With normal speed, that's faster, faster, right? Or you can add different kinds of transportation tour, right? And then we find it out. Well, they are quite similar, you know. So we are going to create a parent. A parent can take similar method or attributes, right? Get up. So then we create another one, transportation, right? Transportation tour. I think transportation is wrong. Then you probably wanted to change to vehicle property, right? Then they have the relationship, right? Just what's the relationship between vehicle and oil, the four relationship? Cherry, what's the relationship between these two? There. What's the relationship?
I don't know.
Okay, Brian, what's the relationship? Inheritance. Okay, so how can we draw? Annotation. What do you mean annotation? Oh, I know what you mean. That is a triangle? Okay, a triangle. Inheritance. Alright, so we take a move, right? Up to vehicle. That inheritance. Okay. So then we don't need to write this. We don't need. Alright. If we have a move here, we don't need to write it, right? Because we are going to have everything from parents. And this move can override it, override. We have polymorphism. And now if we wanted to add more classes, like truck, van, minivan, that's, then also, you know, we got to make sure they have move. Okay, move, they can override it. It's a kind of polymorphism, all right? The more we add, then we have a lot of overriding, probably under here, you know, under Street Racer or under Formula One, we have other. Not suppose that we also have others, or you probably too right. It's a multi-level. Okay, multi-level. We can override this, and the child of Street Racer can also override it, alright? Then may have problem, right? Because the child, you know, so you have a lot of overriding, may have problem. Okay, we just talk about dependency. Okay, jets. Here, multi-level. multi-level is override, right? So, do you understand that? Multi-level, it's a lot of level. So, well, it might have problem with that because when we go deep, all right, a lot of overriding, then, well, sometimes it's out of control. It's hard to maintain, hard to be reused. Okay, so why is that? And so you take this for example, just which one depends on which? Child depends on parents or parent depends on child?
Child depend on parents.
Okay, child depends on parents, right? So whenever parent change, child will be changed, right?
Okay.
Yeah. Okay. So that is the problems of multi-level, and so it's multi-level inheritance. Multi-level inheritance. Okay. And tell me what is multiple inheritance? Same? Are they the same? Multiple inheritance. Raise your hand if you understand this. The idea.
Multiple, maybe have a lot of parents, but not any language can use this.
You mean that? Multiple inheritance, right?
Yes.
It is allowable. It is allowable in Java. Can we use Java? No, to implement more than one parent.
Java maybe cannot do this.
Why?
I know.
You want to tell me why it's not allowable? Raise your hand if you understand that. Oh, nice. Very nice. Okay, answer. Okay, Chen.
Java can multiple inheritment, but
Can
on-
or cannot? Java?
can.
No.
But I search on the website say
Okay,
it
then
can,
go on. All right.
but it only can implement for one father. Only implement one father. If I
It's a can, but it's only one father. That means cannot. It's a can, but can only one. That means cannot.
okay.
I wanted to ask why cannot. Right?
And so Java can implement two abstract class in same time. We can implement two interface at the same time because interface
You said it again. You said can or cannot?
cannot
Cannot. All right. Mm-hmm.
Uh,
Why? Tell me why.
because in interface
No, nothing relates to interface. Tell me why. No, what's this not?
there are two parent class and have a speed attribute. So when child implement the two parent, they don't know which speed they should
Correct.
implement.
Yes. I wanted to hear this. All right. So that's why. Don't memorize that. Just you should know why. All right. So know why. If we have two parents, they have the same name. Which one to take? All right. So there will be problem. So that's why. You got to know that. All right. So that's why it's not allowable. But if it's interface, we have other interface, yes. What is this another interface? Okay, for this interface, right? We can implement that. Or you want it more? Fine. It's okay. All right. But no, not this. Right. So probably you read that it's okay for multiple inheritance. We don't call this inheritance. This. All right, multiple. No. So multi-layer is different from multiple. All right. There will have something wrong with that, right? So that we call this inheritance conflict. Inheritance conflict. All right. It means something wrong will happen. All right. So what is that? Could be the same attribute, the same matter. All right. Which one to inherit from? It's inheritance conflicts. And what about the other inheritance conflicts? What others? Inheritance conflicts. Right, you understand that? Okay, tell me that. What other inheritance conflicts?
The two-parent class has the same method but different body type, different body and inheritance too that can make conflict.
Still already the same? No. The same. I wanted to know other inheritance conflicts. Raise your hand. Just know that inheritance conflicts. That come to you. Right. So other kinds of inheritance conflicts. Already talked about that. We should know that inheritance conflicts. Hank?
The other inherent problem, give an example. Like a parent is vehicle, and the child has car and the bike, but the bike is not a vehicle. The is a
You
problem.
talk about the risk of substitution principle,
Yes.
right? So you're talking about that. Yeah, this is something. Yeah, that's good. That means that they don't have, we cannot replace.
Yes.
You talk about that, right? That's quite strict inheritance. And what I said that, okay, inheritance conflicts, that when we wanted to create these kinds of relationship, all right, inheritance, right? Whatever your parents have, it should pass this on to the children, all right? So we know that. Not the vehicle only, but also include the friends of vehicle. Hank, you know that, tell me that.
Yeah.
Yeah,
Yeah.
for example, tell me that. What assets?
The
Friend.
the child must be the parent.
Child must be the parents.
Can
Parents' friend. Parents' friend will be
parents friend will be
parents' friend.
can changeable.
Can or cannot.
Can
Have friends. We have friend. Then, what about children also have a friend or not?
Yes.
What if not? What if not? So you say yes, right? So all the children should have a friend, right? Okay, so that is the thing. What if the friends of vehicle is not a friends of, or not suitable for the children? That's wrong. There will be inheritance conflicts, all right? The vehicle has a friend. Vehicle, will have this. And all the children also, need to carry some, right? But what if not? So there will be inheritance conflicts. You got it? So that's the problems inheritance. Inheritance is quite, quite helpful for designer because just inherit from parents, right? But we should be careful that something might go wrong, right? So for this example, I will not go that wrong. And here we just said that they have the same matter mover, all right, vehicle. And then we find it out, well, and last time I told you that I want you to practice abstract class and interface. You wanted to, combine them all together. So here, it's override it, and whenever we add it, we override it. And the one is changing often, right? So this is the one change often. So we wanted to take it out. So now we take it out. So here, we may use this as move algorithm, and we wanted to change. Of course, every children should have the relationship. Okay. So we take this changeable method out, become move algorithm. And all the move will be conducted by move algorithm. So here we have move. Whenever vehicle wanted to move, ask move algorithm to move. You should move that, right? We gotta make sure move algorithm has a method move, then they can move. So street racer, right? Street racer inherits because vehicle has move algorithm as a variable and ask to move. But of course, what I said is ask, ask move algorithm to move. Here we have the aggregation, whole and part, whole and part. If we have this whole and part, right, on fence, which one depends on which? Yeah, you can. Whole and part. So which one depends on which? Which one's power is over the other? It's a whole. It is the vehicle or the move algorithm. Which one depends on which?
And vehicle depend on move
Move algorithm.
algorithm.
Okay, that's good.